Hello dear students, in this session we are going to discuss irrationality of numbers. Let us see what all questions we will discuss. So we will discuss these questions: root 2 as irrational, 6 plus root 2, 3 minus root 5, addition, subtraction, multiplication, division, and then root 5 plus root 3, and in general root p plus root q. I will take this video a little faster, and let's check the first slide. How to prove root 2 as irrational number? To prove root 2 as irrational number, what we need to do? Let us assume root 2 be a rational number. Let root 2 be a rational number. If it is a rational number, we can write it in the form of p by q. So root 2 is equal to p by q. In bracket, what you need to write? You need to write p and q are co-prime integers and q is not equal to 0. What is the meaning of co-prime integers? Whose common factor is 1. You need to write this here. Now doing by cross multiplication, we will get this by cross multiplication. After squaring both the side, 2q square is equal to p square. Now you can see if q square is divisible by 2, then p square will also be divisible by 2. So we can write 2 divides p square. So 2 divides p also. This is a theorem. Now if 2 divides p, it means we can say what is p? P is 2c. We can write where c is some integer. Let me write for some integer c. For some integer c. Now substitute the value of p is equal to c in this equation. That is 2q square is equal to 2c whole square. Now simplifying, we will get what? 2q square is equal to 2c square. From here we can again say that if this is divisible by 2, then this must be divisible by 2. So 2 divides q square. So 2 divides q also. Now you can see 2 divides p also and 2 divides q also. It means 2 is a common factor of p and q. But p and q are co-prime integers having factor none other than 1. You need to write this statement. P and q are having common factor 2, this line, and then but p and q are co-prime integers having common factor none other than 1. And last line is, so this is a contradiction and hence our assumption is wrong. Therefore root 2 is an irrational number. So these are the steps. You need to write it. Pause the video and you can write the steps. Moving to the next question. Question number 2. How to prove 6 plus root 2 as irrational? To prove 6 plus root 2 as irrational number, sometimes it is given for 5 marks. Then if it is given for 5 marks, then first you need to prove root 2 as irrational. After that we need to prove 6 plus root 2 as irrational number. Let's start. Let us assume 6 plus root 2 be a rational number. If it is a rational number, we can write it in the form of p by q, where p and q are co-prime integers, is equal to p by q. We need to write in bracket p and q are co-prime integers and q is not equal to 0. Now what you need to do? Keep root term in the LHS and remaining all terms in the RHS. For simplification, we can take LCM and it will be p minus 6q upon p. LCM q and 1 LCM is q, then diagonal you can multiply. P into 1 is p, q into 6 is 6q. Now you need to mention why this term p minus 6q upon q is rational. It is rational since p and q are integers. 6 is integer only. So this term is rational, but root 2 is an irrational number. So first statement, what you need to write? P minus 6q by q is rational since p, q and 6 are integers. Second statement is, but root q is an irrational number. So this is a contradiction, hence our assumption is wrong. This will be the third statement. And last will be, therefore 6 plus root 2 is an irrational number. Now let us discuss the subtraction part. It will be same as the addition only. Question number this, 3 minus root 5 is an irrational number. Same first line will be what? Let 3 minus root 5 be a rational number. Let 3 minus root 5 be a rational number. If it is a rational number, we can write it in the form of p by q. 3 minus root 5 is equal to p by q. In bracket again we need to write p and q are co-prime integers and q is not equal to 0. Now you can keep root 5 in the RHS so that it will become positive, and p by q in the LHS it will become negative. Now take LCM in the LHS. LCM will be q. 3 into q is 3q. P into 1 is p is equal to root 5. Now again the first statement, what you do write, that 3q minus p upon q. This term is rational. This term is rational. Why this is rational? Because p, q and 3, these are integers. This will be the first statement. 3q minus p by q is rational since p, q and 3 are integers. But root 5 is an irrational number. So this is a contradiction, hence our assumption is wrong. Therefore 3 minus root 5 is an irrational number. ऐसा हमने prove करना है हमें. Now moving to the next question, multiplication part. How to prove 7 minus root 5 as irrational number. So again let us assume 7 root 5 be a rational number. If it is a rational number, then it can be written in the form of p by q. Let us write it. 7 root 5 is equal to p by q. Again in bracket we need to write p and q are co-prime integers and q is not equal to 0. What we need to do? Keep root term in the LHS and remaining all terms in the RHS. So it will become 7 is in the multiplication, so in the RHS it will come in the division. Now again we need to write what? Why this number is rational? P by 7q is rational since p, q and 7 are integers. This will be the first statement here. P by 7q is rational since p, q and 7 are integers, but root 5 is an irrational number. So this is a contradiction, hence our assumption is wrong. Therefore 7 root 5 is an irrational number. Now let us discuss the irrationality of irrational number for division part. So again 3 by 2 root 5. Let us assume this as rational. Let 3 by 2 root 5 be a rational number. If it is a rational number, we can write it in the form of p by q. Let's write it. 3 by 2 root 5 is equal to p by q. In bracket we need to again write p and q are co-prime integers and q is not equal to 0. Now what we need to do by cross multiplication first, so that we can put root term in one side. Now keep root 5 in the LHS and remaining all terms in the RHS. 2 and p, these are in the multiplication, so it will go in the division. Now again what we need to write? First statement will be 3 by 2. 3q by 2p is rational. ये rational है because p, q, 2 and 3 are integers, but root 5 is an irrational number. So this is a contradiction. Hence our assumption is wrong. Therefore 3 by 2 root 5 is an irrational number. If this is asked for 2 marks or 3 marks, then we need to do like this. If it is asked for 5 marks, then first we need to prove root 5 as irrational and then we need to proceed like this. Okay. So moving to the next part. Next question is how to prove. Now we are having combinations of addition and we can say subtraction and multiplication both. So how to prove this? Similarly we need to start. Suppose let 2 minus 3 root 5 be a rational number, is rational. If it is rational, then it can be written in the form of p by q. 2 minus 3 root 5 is equal to p by q, where p and q are co-prime integers. P and q are co-prime integers and q is not equal to 0. Now what we need to do? Keep root term in the RHS so that it becomes positive. 3 root 5 will become positive and p by q in the LHS. 2 minus p by q. It is in addition, so it will come in subtraction. Take LCM. It will be 2q minus p is equal to 3 root 5. Now we can put 3 in the LHS, so it will become 2q minus p upon 3 will come in the denominator is equal to root 5. Again what we need to write now? 2q minus p by 3q. This is rational since p, q, 2 and 3 are integers. This will be the first statement. Second statement will be but root 5 is an irrational number, and in the last we need to write so this is a contradiction, hence our assumption is wrong, because in the LHS we are having rational number and in the RHS we are having irrational number. So this is a contradiction, hence our assumption is wrong. Therefore we will say that 2 minus 3 root 5 is an irrational number. Now let's move to the next question. Next is how to prove root 5 plus root 3 as irrational. So let us assume this be a rational number. Let 5 plus root 3 is rational. If it is a rational number, we can write it in the form of p by q or a by b, whatever you need to write. In the bracket again we need to write p and q are co-prime integers and q is not equal to 0. Here first you need to take one root term in the RHS and then do squaring both the side, because if you will do squaring both the side in this step only, you will get root 15 and then you need to explain why root 15 is irrational. So let us take one root term, that is root 3 in the RHS, and then do squaring both the side. We are doing squaring both the side. So in the bracket you need to write squaring both the side. Do mention the steps whatever you are performing. Root 5 square is 5. This is a minus b whole square, that is a square plus b square minus 2ab. Now what you need to do? Put root term in one side and remaining all terms in the other side. I am keeping 2p by q root 3 in the LHS so that it will become positive. 2p by q root 3 is equal to p square by q square plus 3. 5 will come in the RHS, so it will become minus. Now what we can write? 2p by q root 3 is equal to p square by q square, or 3 minus 5 is minus 2. Now what you can do? You can do simplification, that is LCM in the RHS, p square minus 2 square. Here you can see we have 2p by q. If we will take it in the RHS, then it will be reciprocal, that is q by 2p. Can we cancel q and q square? So it will become root 3 is equal to, in the numerator it is p square minus 2q square, and in the denominator we have 2pq. Now again this will be the same question, why this term is rational. So first statement will be p square minus 2q square upon 2pq. This is rational since pq and 2 are integers. Next statement will be but root 3 is an irrational number, so this is a contradiction, hence our assumption is wrong. Therefore 5 plus root 3 is an irrational number. Let's move to the next question. Next, or the last question. This is our last question, so let us focus. This is an important question. Let root p plus root q be a rational number. If it is a rational number, we can write it in the form of a by b or p by q. P and q are already used, so I am using a and b is equal to a by b, where a and b are co-prime integers and b is not equal to 0. Here you need to write. Now same question like we did before. Put one root term in the RHS and then do squaring both the side. Now let's do squaring both the side. Squaring, you need to write squaring both the sides. Now do squaring of this, that is based on x minus y whole square, that is x square plus y square minus 2xy, and in the LHS we will have p. So now again what we need to do? Put root term in one side and remaining all terms on the RHS other side. So keeping this to the LHS, we will get 2a by b root q is equal to a square by b square plus q, and p in the RHS, so it will become minus p. Now do take LCM here and simplify it. What we will get? 2a by b, 2a by b root q is equal to, taking LCM, b square is LCM, here we are having 1 and 1, so a square plus b square q plus a square plus b square q and minus b square p. Take 2a by b in the RHS so that root term will be in the LHS. A square plus b square q minus b square p upon b square. If 2a by b you will take to the RHS, it will become reciprocal, so b by 2a, b gets cancelled, so the final step will be root q is equal to a square plus b square q minus b square p upon 2ab. Now what we need to write? We need to write why this term is rational. This a first statement will be what? A square plus b square q minus b square p upon 2ab. This is rational since a, b, p, q and 2 are integers. Next statement is but root 2 is an irrational number. So this is a contradiction, hence our assumption is wrong. This you need to write. After that in the last line you will write hence root p plus root q is an irrational number. That is all. Thank you.